is the brand new BAC Mono R. It looks absolutely insane from the outside, a complete beast, and I'm actually going to be the first person outside of the company today to drive this. Formula 1 parts, Formula 3 parts, I think it's going to be insane. Let's jump in.
With a price tag of almost £200,000, each car conceals a host of groundbreaking tech and high-end engineering. A tubular frame chassis contributes to the car's incredible lightweight of only 555 kilograms. A 2.5-litre four-cylinder engine delivers 137 brake horsepower per litre, a world record for a road-legal track car. And a single-seat cockpit is tailored to each driver's body shape for a unique racetrack experience. And today, expert racer Katie is getting in the hot seat.
Perfect, I'm in. There's no getting out now, no going back. Okay, green light, that means ready for action. God, the vibrations through the back of my seat already. I haven't even revved yet and I can already feel it. Let's go. I still can't really get my head around the fact that this is a track car, but also a road car. It seems like it was just born to be on a track.
She's got the world-famous Goodwood racetrack all to herself.
It kind of pins you back in your seat as soon as you accelerate. It's such an amazing feeling.
To really test out what this car is made of.
I mean, how cool is it? Driving around Goodwood Circuit on my own in a BAC Mono R version. Only 30 being produced, not yet released for their owners. If there's any car that I've driven that wants to be fast, this is it.
So can they create a road-faring supercar that breaks records on the track? The secrets lie in their Liverpool factory. This modest 1,000 square metre facility is hardly the place you'd expect to produce a supercar. Each car is handcrafted by only 15 manufacturing staff, who are delivering just 4 cars each month to customers around the globe. All under the watchful eye of company founders and brothers Neil and Ian Briggs.
It's a Formula-style architectural layout. The driver sits in the middle, the engine and the gearbox is all in one straight line. It looks like nothing else. It's got its absolute own identity.
It takes 5 weeks to take thousands of components and assemble them into a finished car rolling off the production line. The build begins around the framework of the chassis. Designing all their own parts, this small enterprise teams up with hundreds of external suppliers who provide several custom-built components manufactured around the UK.
This is the latest chassis that's just arrived, and the lads are just bringing it into position here now on chassis dress. This is the area where, in essence, we build all of the chassis items, powertrain, steering, suspension, etc.
Brothers Ian and Neil grew up with a fascination for racing. So it was only natural for these two petrolheads to follow their passion. With Neil's engineering mind and Ian's talent for design, they founded their eponymous company in 2009. Releasing their first car only 2 years later solidified the Briggs brothers in the world of supercars. Neil Briggs is chief engineer of the company and oversees the transformation from the chassis into a track racing supercar.
The chassis itself has been optimised for Mono R. It's a tubular space frame chassis by design. This whole thing, when it's all put together, is 46 kilos.
Not only are the hollow steel tubes super light, but they are also arranged to provide rigidity.
So the triangulation on the car is all there to make sure that the loads are evenly distributed throughout the chassis, and that's pretty much why the chassis looks a bit like a Union Jack here in this case, because it is the optimum structure for the car. It's very, very stiff torsionally and in vertical lateral bending that basically forms the perfect platform for the vehicle dynamics and the performance of the car.
A car hurtling along a track at 170 miles per hour could pull huge G-forces in the corners.
This was recently measured to have similar stiffness, incredibly, as a Formula 3 car, which is way beyond what standard supercars are designed to.
To rub shoulders with the big guns, strength and lightness are what a track car needs.
The rollover protection system, which we call the ROP structure, is actually designed to the similar load case, believe it or not, as Formula 1 cars. We thought we should go to the ultimate level of the load case.
This tubular chassis design provides a cockpit that is safe while also maintaining stiffness on the circuit.
Ultimately, it means that it's a super safe structure for the driver, so the driver's safety is optimised around all of the various different structure. What it means is that it provides a very stiff chassis basis for all of our vehicle dynamic tuning work that we do. It's one of the many reasons why the car is so incredibly quick around the track and breaks so many production car records.
On the track, Kate is testing the impact of this chassis design on the car's handling.
One of the reasons that this car is so agile and so responsive to the steering is the chassis. Typical race car style, it's a tubular space frame, which provides so much strength. It's such a solid base for a car to be built from.
Holding rigid in tight corners and chicanes, the strength of the tubular frame really shows when the car hits the apex.
And you can really feel it as a driver, you know, every time I turn into the corner, I can feel the strength, how rigid the platform is. And I can see so much feedback from a racing perspective as a racing driver. It's exactly what you want to be feeling, to have the confidence, to know that the car is going to go exactly where you want it to go in the right moment. You have to be really switched on as a driver, because every single little input you make into this car, the car responds to it.
We're trying to create a unique driving experience, so we're having to go to the nth degree from the concept of the car all the way through to every material, every design solution is selected to deliver that ultimate driving performance.
The secrets of this supercar's success are hidden beneath a unique graphene-infused carbon fibre body. World-first hybrid carbon alloy wheels have helped it to break track records around the globe. And with the production run being limited to just 30 cars, they get a lot of personal attention.
The BAC Mono is a bespoke product, and it's designed purely for that driver. And so we can go to a level of bespoke detailing that's just not possible for the bigger companies. That's probably what separates us the most from the big manufacturers.
But what makes the champion racers of today so formidable on the circuit? Track racing supercars might not even exist if it weren't for the trailblazing innovations unlocked by one of motoring's great game changers.
No windscreen, no roof, no doors, and it's all very mechanical. But because it's so mechanical, you can feel everything the car's doing. In a car like this, it's an adventure.
At the world-famous Prescott Hill climb,
Every ripple of the tarmac, every bump of the road, you can feel through your bum.
vintage car restorer Duncan Pittaway is tearing up the track.
It really is driving by the seat of your pants.
In one of the most successful race cars of all time.
This is a 1925, the Type 25 Bugatti. It's the most fabulous thing. It's a 2-litre straight 8. It's only one of the most exciting cars I've ever driven. It's just a delight to drive.
Built by car maker Ettore Bugatti, the Type 35 is one of the most successful track cars of all time. Sleek and elegant, the ready-to-run racing car weighed 750 kilograms and could reach incredible speeds of 118 miles per hour. This unparalleled icon of the 1920s is no typical track car.
Fabulous thing.
It's an engineering masterpiece.
Up until the Type 35 Bugatti, Grand Prix racing was all about power and speed and big engines and heavy. They didn't really give any thought to lightness and design. Ettore Bugatti approached the whole subject of car design in a different manner. The alloy wheel was something that Ettore thought about because it's not only beautiful, but also very functional. It meant that the brakes would be cooler, the wheel itself is lighter. The other thing he did, which nobody else had done at the time, front axle. Looks like a normal beam front axle like any other car, but he decided he can cleverly make it hollow. So it's very light. It's probably half the weight it otherwise would be.
With weight-saving innovation at the forefront of Bugatti's design, the Type 35 is the godfather of today's road and track-faring race cars.
The secret of the Type 35's success, apart from its looks, which are devastatingly good, but it managed to combine lightness of weight, perfect steering, fabulous brakes. It was such a complete package.
Only 340 Type 35s were ever produced, and nearly 100 years later, only a few survive today. Thanks to Duncan, this one still runs like new. Almost.
There should be a clock here, but that fell out years ago. And I think these ones was when it had lights on, but they all disappeared a long time ago. They're not important. Saves more weight.
But you don't need dials to drive fast.
When you're sat in the open, with your wind in the hair and flies in your teeth, 120 miles an hour seems extremely fast. It became the benchmark for other manufacturers. This is just as quick as most modern cars, but it's just so much more exhilarating in every respect.
The groundbreaking technology made it the only car of its time that was as welcome in public traffic as it was on the racetrack.
And it's an outstanding road car as well as a good race car. It's one of the only cars that you could go to a showroom on a Friday, drive it straight to the race meeting on a Saturday, and race it. I have a grin from ear to ear when I'm driving this car on the road. And I feel the luckiest man on the planet to be able to do this.
Track cars have come a long way since the Type 35. Almost 100 years later, this rapid racer makes even the 118 miles per hour Bugatti seem slow.
It actually really does feel like I'm in an F1 car. Let's see what she's all about.
Luckily, rally driver Katie Munnings
This car's just dancing around the track.
isn't afraid to put her foot down.
This car just wants to be driven fast.
With the racetrack all to herself, she's opening up the throttle to see what this creature can do. Engineers have set themselves the challenge of creating a speedy single-seat supercar. And the secret of its track record-beating pace is held in their British facility.
Mono is unique amongst supercars in that the car's effectively made to measure. The seat's moulded for the driver, the steering column, the pedals, everything's made to the driver. This is where the journey for the customer really properly starts.
And at the heart of each car is a tailor-made, unique driver cockpit.
This system first came out in F1. We've taken this technology and used it in exactly the same way as we do in motorsport.
Alex Powell specialises in creating the perfect driving position for each individual driver's comfort and safety.
So at the moment, I'm laying out the bag for the driver, and this will be their seat. Each one is completely different, and it's completely tailored to the driver's needs. So it will mould perfectly to them. It's like a bespoke suit for them, to the point where you'll even be able to see the pockets in their jeans or the zip lines or the tape lines on any of their jackets.
This seemingly simple beanbag is the state-of-the-art tech used for Formula One race cars. Alex will fill it with resin and shape it to the driver's body, providing a super safe and comfortable cockpit. But like the Type 35, every part of this car also needs to be light.
We're going to have a finished weight of about 900 grams versus your standard road-going seat with all of its electrics and leather that could weigh as much as 30 kilos. So there's a real weight saving here, along with the fit and safety improvement. This is where we can really tune how much support you want at this stage, so we can adjust the height and the pressure and how far around you it comes. Height's good, distance to the pedal is good. It looks pretty much perfect.
The result is a unique racing-style bucket seat, tailored perfectly to one driver.
Are there any changes that you'd like to make to the seat?
No, I think I'm good.
Fantastic. Well, in that case, I'll start increasing the vacuum slowly and we'll begin the curing process.
As the seat begins to cure, our customer has got about 30 minutes where he has to sit still while this seat is moulded to him. That's the finished result. You end up with something that's moulded to the car on one side and moulded to the driver on the other.
And rally driver Katie is getting to experience for herself the effect of customised cockpit configuration.
There's no glamorous way to do this, really, is there?
The pit crew have adjusted every detail to give her the ultimate experience in the hot seat.
Such a different driving style to how we sit in rally. Most surreal experience. I don't think I've ever been this close to the ground before in a car. But this is like a completely different driving style.
When racing on the track, precision engineering means everything.
The seat is just like if you're in a race car, so you let the seat mold into the shape of your body, but it actually reduces the weight. So this is contributing to such low weight on the car of 555 kilograms in total. When you then feel it on a track, it all adds to the performance, and it adds to the feeling of how strong the car is. Such a race car vibe, isn't it?
To gain the pole position in creating a supercar for the road and track requires revolutionary engineering. So at the Liverpool factory, innovation is at the heart of the operation.
Technology and innovation is really important because we're chasing grams with things like niobium in our metals, graphene in our composite parts. We're trying to create a unique driving experience, and so we've got to have the lightest possible car with the weight as low as possible to deliver that performance.
This racer sports a Formula-inspired ram air inlet system, delivering pressurised air into the engine, providing rapid acceleration from 0 to 60 miles per hour in 2.5 seconds. And over 40 3D printed components, delivering otherwise impossible weight savings. Every detail of this car is fine-tuned for track performance, right down to the wheels.
I think it's fair to say that we're fairly obsessed with weight, and that's fundamentally why our innovation pushes towards trying to save weight. When it comes to weight save, the wheel really is the holy grail.
But what's the secret to making wheels that are both super light and strong enough to handle the rigours of the road? British touring car champion turned wheel engineer Matt Neal knows exactly what it takes to win. He's behind the scenes at Rimstock in West Bromwich, unveiling the secrets to producing one critical component that helps other supercars reach record-breaking speeds.
A lot of the supercars made around the world, the wheels are actually made in this factory. Those cars go on to set records. You know, I've seen some of the cars with our wheels on doing it in excess of 250 miles an hour, and that's pretty special.
With his expertise, Matt helps this specialised facility to develop revolutionary rims for the racing big leagues.
What is very relevant is the materials you make them out of. It has a bearing on performance, acceleration, you name it. So wheel weight is a real critical factor.
Starting with the key ingredient, aluminium.
This is how a supercar wheel starts life. These will go into the automated saw, and they're chopped depending on the size of the wheel. And if we come around this side, that's the sort of slug log that you're going to get out of it. That one in particular is going to be around about 50 kilos, so I'm not going to try and pick it up for you. So this is when go into the oven for between 4 and 5 hours, and they'll be running at about 500 degrees C. That's to make it more malleable.
Once the logs are super hot, things can really start to take shape.
Okay, if we go around here, we'll be able to see the log being unloaded off the preheat oven into the actual forging machine itself. And this is quite a restricted area. We all have to keep it at a safe distance here.
Only highly trained technicians can get anywhere near the forge, where a powerful hydraulic ram will compress the aluminium logs under 120 tons of pressure.
The forging process closes up the grain structure, and that means you can machine it thinner and lighter. So it'll come out looking like one of these. That is your basic pancake. Still very dirty, and it's still very much in a free form. And it comes into the flow former up here. The flow forming machine will basically shape it into the basic form of what that wheel's going to be. This is when it first starts to take form as a wheel. So you can see at the top, this wheel's just been ejected off it. And if we follow the track down, so that is basically taking now the form. You see the tyre humps, so the heat of that is still about 150 to 180 degrees C. Even fry an egg on it.
But there is one final modification before this solid disc is fit for a supercar.
So then come into the milling side. You've got your basic pre-turned wheel, nice virgin face, ready for milling. So in here, you can actually see the wheel will move around and the tool moves above it. And that's a lengthy process. That could take anything between, depending on the style of the wheel, between 2 and 10 hours per wheel. So if a milling machine working 24/7, you'll get 2 wheels a day. The ultimate thing that comes out of there is the sexiest thing you'll ever see on the road.
After a lick of paint, these rims are race ready.
What's hard to believe is you've seen the logs come in initially, which is just a 50, 60 kilo chunk of aluminium. And that turns into a 9 or 10 kilo wheel. The record-breaking speeds we see around the racetracks of the world wouldn't be possible without the technological input and the weight saving. And that makes you very proud, makes us all very proud. So to get to this product, it's quite unbelievable.
When every second counts, the alloy wheel has to be pushed to the limits. So for this track supercar, they've actually reinvented the wheel with their very own innovation.
This was a world first when we first launched it. What we call it a carbon hybrid wheel because it's made up of 2 different materials. We use carbon for the rim, so this is the piece that goes right around the outside. And then the centerpiece is made from an aluminium center section. That benefits us in every single different application of performance on the track, so under acceleration, turning, change of direction, braking, etc.
And Katie is putting them to the test.
The wheels actually save 2 kilograms per wheel, so that adds up to 8 kilograms overall, which is massive when you think the total weight of the car is 555 kilos.
By marrying 2 materials, these wheels are tough and light enough to handle extreme forces on the track.
You can just feel it, how responsive it is. Just as I'm turning, it just feels like a race car, to be honest.
Back at the factory, there's another secret that gives these wheels traction on the tarmac. At the next pit stop on the production line, the car's suspension is calibrated.
This is where the rear suspension is fitted to the rear of the car.
Neil leads the engineering team in bringing race suspension tech to the road car.
It's a push rod system. It means that there's an attachment via this push rod, which is here, which basically links the wheel into this rocker, which is attached to the anti-roll bar and ultimately the dampers. The more that we can put weight towards the centre of the car, it means that we have the perfect weight optimisation left and right.
Enhancing a supercar for the track means employing techniques usually reserved for the big players of the motorsport world.
Pushrod suspension systems were first developed by Formula One teams. We couldn't perform the way that we do without this vehicle architecture and without this style of suspension system. It's a very, very weight-efficient system, and also from an aero perspective, it's very efficient as well. So it really is the holy grail of suspension systems.
And there's only one place to test out F1-style components.
The whole point of building a car that's good for a track is bringing the centre of gravity central and down, bringing the weight down to the middle. And that's exactly what the push-rod suspension does on this car.
On the track, this centralised weight should translate to pinpoint accuracy.
Now, in terms of driving and in terms of the feedback, I cannot believe how responsive it is to my steering. Combined with the lightness of the car, that just gives you such a stable feeling as a driver.
This technology is really pushed to the limit when each driver makes their own adjustments to suit their unique driving style.
You can even adjust the suspension. This is just like my rally car. You can adjust the damping systems to get the feedback that you really want. I feel like I'm at home.
There isn't anything as focused as this as a production car, and so it's no surprise. Whether you're a designer, an engineer, a mechanic, everything is focused on making that machine as good as it can possibly be. We measure performance as a lap time, not as a top speed, or even as a 0 to 60. They're just byproducts.
This supercar and circuit may be the perfect match. But what happens if you take both the race car and the track to the extreme? Deep in the heart of the Florida Everglades lies a mammoth motoring convention like no other.
So this is swamp buggy racing, a submerged track down in the Florida Everglades. These cars going upwards of 80, 90 miles an hour. I've never seen anything like this. This is madness.
Engineer Dan Dickrell is leaving dry land behind.
Get the thumbs up and we're good to go.
To take on a track of an entirely different kind.
You ready for the cold one? Yeah, man,
The Naples Swamp Buggy races have been a slice of Everglade life for over 70 years. As race fever sets in, thousands descend upon the peaceful wetlands and the festival booms with the roar of engines.
I got wet. Just a little bit. Oh my God, that was so much fun though. Thanks, man. No problem. Appreciate it.
But to take on such treacherous terrain requires a seriously souped-up car, if you can call it that.
So this is an excellent example of a swamp buggy racer. It kind of looks like a car, but also kind of looks like a spaceship at the same time.
Designed with speed in mind, these muddy machines come in all shapes and sizes and can cost up to $100,000 to build. But keeping them afloat on this unusual track requires some special engineering.
Since it's opened up, we can see all the internals. Got a small block engine, carburetor, this huge air intake, bringing clean, fresh air into the engine, creating a lot of power. Look at these wheels. These are absolutely custom wheels. They're 67 inches tall. These are actually tractor tires, 2 of them that are cut in half, composited together. These scoops help move the buggy racer through the deep, muddy parts. Coming around the back, we can see the massive suspension system on these rear wheels as this thing bounces through the water. It's such a really cool piece of engineering. and these things are gonna fly around the track.
This mud-eating monster is Backdraft, custom built by owner and racer Dave Brewer.
Hey, Dave.
Hey, how you doing, man?
This is your machine. This is the Backdraft, right?
This is the Backdraft.
Nice. What is it like out there?
It's a very unique feel. There's a lot of G-force that goes on, believe it or not, running, 85, 90 miles an hour through the mud and water. We're kind of just in there hanging on for dear life. It's almost like, I would say, driving a boat most of the lap, and then the other half in the corners would be like driving a stock car.
So how do you feel about your chances today?
I feel like my chances are pretty good. We won the event just this past January. It seems to be running really well. I think we're going to bag them this weekend.
Oh, cool. Good luck, man.
Well, thank you.
See you afterwards.
And I'll see you out there.
As one of the fastest machines on the mud, Dave's hoping Backdraft can be victorious in today's big race.
It's going to be the loudest it's going to be all day. Probably the wettest. All right, here we go. 1, 2, here we go! Oh, wow! Oh, yeah, no, he's way ahead. Here comes Backdraft. Oh, he's absolutely killing it. All he has to do now is basically not crash. Right on. Nice. Hey, I crossed the line. Oh, wow, he crushed that one.
Swamp buggies are one-of-a-kind track vehicles, and motorsport doesn't get much more extreme than this.
But I gotta say, pretty sure Dave's happy with the outcome today. Woo! There he is right there in Backdraft. Good job. Congratulations. So, swamp buggy racing. Pretty intense.
Solid ground may make for a more traditional racetrack, but it takes a pro test driver behind the wheel to truly conquer it.
It's got 137 brake horsepower per litre, which actually makes it a new world record for road-legal, naturally aspirated cars. Ollie's been a test driver with BAC for about 7 years, so that's why he's here really pushing it to the limits today. When we watched even his warm-up laps, Ollie definitely knows what he's doing behind the wheel. Coming in, his feedback to the engineers, just listening into snippets of it. He's really dialed in and he's really in tune with the car.
But to fully unleash this single-seat supercar demands some serious hardware. In one of the most crucial stages of production, the drivetrain systems are equipped. With the car being lightweight and streamlined, all it needs now is some juice.
This engine really is a new reference. In fact, it's actually a world record braking engine.
To smash lap times, this car is rigged with an engine of unprecedented power.
If we divide 343 by 2.5 litres, which is the capacity of the engine, that will give us 137 brake horsepower per litre. So it's a new world record in terms of specific output for a normally aspirated engine.
To reach high power output, most track cars get a helping hand from turbos. But the engine in this car is passively fed air through some clever engineering.
This is the ram air intake for the engine. That allows us to force more air into the engine. That allows us to therefore add more fuel. And because we're revving the engine higher to 9,000 RPM, we therefore make considerably more power. So not only do we have incredible power, the car just keeps on accelerating and accelerating and accelerating because we're actually forcing more and more air in as speed increases.
On the track, this racer, with its high-performance engineering, is showing no mercy.
That is so fast. I think the top speed is 170, but it looks way faster than that. And that's a road-going car as well. It's incredible. The power-to-weight ratio is 618 brake horsepower per tonne, which means it's incredibly powerful.
This supercar has taken on tracks around the globe. And today, Ollie's got his sights set on conquering one more.
What's cool is the faster you go, the more power you're given, because the air is funneled through the air intake, and then the engine management system injects more fuel into the chamber, meaning that you actually have a bigger bang, faster car.
With groundbreaking engineering under the hood and a test driver at the wheel, this tiny racer is a force to be reckoned with.
It's so cool to have been here today. To have driven it is a privilege, but also to have seen Ollie pushing it to the limits and working it to its best performance. It was awesome. It's, yeah, a surreal experience.
With this car, Neil and Ian have taken the concept of a roadworthy track racer and added all the secrets of a supercar.
It's back to that single-seater feeling of the vibration of the engine, the rawness, the noise. It's out there with the elements, but that's really what I love about it. You're getting the experience that you want as well, which is raw emotion.
But with a production run of just 30 and every unit already promised to buyers, only a handful will get to spend weekends racing on the track in this car.
This car doesn't try to be good at shopping, it doesn't try to be good at other things. We have one goal, and that is to make a piece of equipment that's just the best it can be at the sport of driving.